Good morning, everyone. The title of this talk was actually chosen for me. It was part of a talk designed for the American Academy of Forensic Sciences, and there's no way the actual talk can be completed in 30 minutes. So basically, you're going to get a summary of handwriting stroke kinematics. In June 1984, I graduated from university with my bachelor's degree in chemistry. One of my professors, the best professor I ever had, she had her first degree was in math and chemistry, her PhD was in physical chemistry, and she also had a master's degree in statistics. For a month, she pounded stats into us. Of course, I remember nothing of it. I then taught high school chemistry for a year, and then on December 22nd, 1986, I began my training in document examination. On the first day, I remember asking my trainer, what do we measure and how do we calculate an error rate? He just looked at me with wide open eyes. What the heck do you mean? Since that day, it's always bothered me that we don't measure. This is nothing new in documents. As Mr. Title, who kindly stole my thunder with his slides on Osborne earlier, 1910, Osborne stated accurate measurements that can be proven to be accurate are of vital importance in connection with investigation of certain phases of the subject of question documents. Osborne was a man, and for those of you who don't know, John Paul is Albert Osborne's great-grandson. He was a man way ahead of his time. He would have been totally at home in a setting like this today. Also said, to avoid possible error and to strengthen testimony, it is desirable in all instances that measurements be made so that they can be reviewed and verified by judge, referee, or jury. So basically, he wants us to be more objective and to demonstrate objectivity rather than just stating a subjective opinion. Again, to emphasize, this was back in 1910. Speaking of signatures, we also always say that no one writes exactly the same way twice. You have variation in handwriting. As Mike explained, handwriting is behavioral. You have 22 degrees of freedom. It varies. So we say if you find two signatures that are identical, one of them or both of them are forgeries. But as Osborne says, you can't speak of this measuring in gross terms. It has to be microscopic terms. And measurements have to be really, really accurate. Genuine signatures of certain exceptional writers' signatures can be found which are nearly identical. And a few years later, or several years later, John Harris also found the same thing in a paper he wrote, that he looked at, I think, people writing the name John Smith, and that lots of them were very, very close together. Actual measurements of the signatures themselves should always be made, and opportunity and assistance should always be given for court and jury to verify all measurements. And this is a picture of Osborne's protractor with his name on it. So this guy, back in 1910, was measuring. As Peter pointed out in his slides, he was very concerned about actually getting his measurements standardized and his measuring appliances standardized. For some reason, in documents, we went away from that. And I think with the technology that we have now, I think it's probably a good time to start looking at that again. So what is the purpose of handwriting examination? Basically, it's a question writing written by the known writer. That's basically what we're asked to do in handwriting examination. We do it now by side-by-side comparison. We begin looking at indicators of different authorship, indicators of disguise or simulation. And I know we have some computer scientists in the room, so by simulation I mean forgery. Because I remember giving a paper to IGS conference and used the word simulation. The computer guys thought I was talking about a computer simulation. The document examiners thought I was talking about forgery. So we use the term simulation. And then we look for indicators of genuineness. Side by side, subjectively, using our training, our experience, what we were taught by our trainers, and what we see over the years. And then we come to a decision. You probably hear the NAS report mentioned more than once today. And in that report, regard to handwriting, the writers of the report say that the scientific basis of handwriting comparisons needs to be strengthened. Recent studies suggest that there may be a scientific basis for handwriting comparison, at least in the absence of intentional obfuscation or forgery. And then the committee agrees that there may be some value in handwriting analysis. Some value. Which is fine. The question is now, how do we increase our value? How do we make ourselves more valuable to the courts? Many people are saying that handwriting is dead. It's not being taught in schools anymore. Paperless society. But it was interesting coming into the gate that the guards wanted a printed pass and not one on your smartphone. So you still had to print the document to get in. I don't think handwriting will die in our time. So how do we improve? Do we improve by measurement? Is measurement the key to go? Some possible features for measurement. Complexity. If you look at a signature, and the question is, has this signature is it genuine or is it forged? One of the first questions to ask yourself is, how difficult will this signature be for someone to forge it? The more complex a signature is, the harder it is to forge. Other features we can look at, in static signatures, we can estimate speed, length, curvature, jerk or smoothness, or tremor, if you like, pen pressure, spacing, slant, and angles. All of these can be measured. Complexity theory was brought up by Dr. Found back in the mid-90s. He says complexity is based on a number of his theory, based on numbers of turning points and intersections. It is a combination of spatial influency features that allows opinions to be expressed. As complexity decreases, the ease with which spatial and line quality features can be reproduced increases. And you can see these three graphs here. Number of concatenated strokes. That's a term that actually Osborne used way back when, in 1910. The more connecting strokes you have, the more complex your signature or handwriting is. If you go across to this one, the more complex the signature of the handwriting is, the likelihood of a chance match becomes less. So you have two people writing the name John Smith. If the basic hand-printed John Smith, not complex, the chance of a likelihood of a chance match is quite high. If you have very complex forms, then the chances of two people writing the name John Smith in two totally different ways is very, very low. And then this one, the last one, the more complex the signature of the handwriting is, the more difficult it is to forge, which is kind of common sense. I was testifying in court a few years ago, and basically it was a doctor's signature on a prescription pad, and the signature was basically a V. And I was asked, is that genuine, is it forged? I said, I have no idea. I said, basically anyone who can hold a pen can do that. So, to no surprise, we found that document examiners perform best when identifying signatures of higher complexity. Fairhurst and Kaplani, who was they are engineers, members of IEEE, of which Dr. Cam is the president, said that if you have complexity, strategies for human authentication may benefit from a clearer understanding of the elements of complexity, and indeed features of a signature model which better reflect a justifiable confidence in judging authenticity. They were working on actual, what's called online signature verification. Someone writes a signature and it's being measured as the person writes. So the more complex it is, the better chance of establishing authenticity. This is some work that's being done in Holland and Germany, and this is a formula that they're working on to calculate complexity. It's not straightforward. I think they're getting some pretty good results, and this may be an older version. I know they're doing more work on this. Is Professor Franco here?
Not yet.
Not yet, okay. Yeah, she's one of the main people behind this. But this is what they're doing, trying to get an equation that you can calculate the complexity of a signature. And if you can do that, then you have a number. You can actually develop a scale on how difficult is this signature to simulate. It will make the job of the examiner easier because now they have something to work with, something concrete to work with. Some of the other work going on using measurement, Dr. Srihari's work on Cedar Fox, Flash ID. I think we're going to hear about that today or tomorrow. And another study done by Chen, Cha, Chi, and Tappert. I found it interesting on the detection of forged handwriting using fractal number estimate of wrinkliness. And this is basically trying to measure how shaky the line is. I think this might be a useful area to look into again. So, to the actual topic of the talk, dynamics and kinematics. Dynamics is concerned with the study of forces and torques and their effect on motion. Kinematics studies the motion of objects without reference to its causes. Many people use the terms in they mix them up, dynamics and kinematics, and I will do the same because I'm not an engineer, I'm not a physicist, and I apologize to anyone in here who knows more about this stuff than I do. So if you're going to study handwriting, if you're going to measure handwriting, what is handwriting? Basically, it's considered to be a sequence of ballistic strokes, comprised of a series of upstrokes and downstrokes, which may or may not be concatenated. Upstrokes and downstrokes influence the way handwriting is perceived. The slant of handwriting is judged by the downstrokes. Downstrokes are found to be more invariant than upstrokes in terms of vertical size. And downstrokes seem to be the information carriers of handwriting. Therefore, if we start doing measurements on handwriting, should we look at downstrokes first as the place to start? As a document examiner, we look at static signatures. It's an ink trace on paper. And we lose significant dynamic information such as velocity and duration. As Mike mentioned in his talk, timing is very, very important, and yet timing is a major factor we lose in a static signature. It's been found that document examiners are not too bad at inferring or estimates of these dynamic features. And Brent Ostrom and Tobin Tanaka from Canada and guest Fairhurst and Linnell, two separate studies, came to the same conclusion. It may be possible using existing techniques to measure size. So let's talk about some recent studies on dynamics of strokes. We looked at 5 parameters: duration, velocity, length, jerk, and pen pressure. Remember, these are all strokes, not of the whole signature. They're all strokes. And these have been published in JFS, Forensic Science International. I'll just give you the references so that you can go find the results in there. Another one in GFS, which is in press. And Mike and I have given several conference presentations and conducted workshops using the data we have gotten from these studies. Now, these studies are on signatures only, not handwriting. And I consider signatures to be separate from handwriting. A signature is an overlearned form of handwriting. In fact, in one of Mike's studies on Alzheimer's, he found that the Alzheimer's patients retained their signature much more than they did their handwriting. So basically, this was the check we used. We asked the writers to write their signature on there as they would like a normal check. We used a Wacom Intuos 3 digitizer pad. And if you saw the one in Mike's photo, his one was much cooler than mine. This one was much older. With an inking pen. The Wacom tablets come with a stylus or an inking pen. We chose the inking pen for two reasons. One, people were writing with the stylus and they couldn't see what they were writing, and that bothered them. Two, with the inking pen, it was very much like a ballpoint pen. And we also got a static signature as well as a dynamic signature. So basically, this was how we took the samples. The person would write one check, put it down, write another one, put it down, and so on. And they couldn't see what I was looking at on the screen. But I was seeing their movements in real time, and they were quite interesting. We used Movilizer software version 4.1, and I think they're probably up to 7, Mike? They're pretty high up now. The tablet has a resolution of 5 microns. It scanned at 200 hertz and had 1,024 pressure levels. We actually used a pressure pen, to calibrate the tablet to actually get gram weight measures. So we had 60 writers, divided them into their signature style, text-based, mixed, or stylized. A text-based signature is one that you can look at and know the person's name. A mixed style signature is one that's written half in text and half stylized. And a stylized signature is one that you look at and say, I have no idea what that person's name is. So we collected 600 genuine signatures. Then we had 60 writers, 60 different writers, simulate 3 signatures, one text-based, one mixed, and one stylized. Each subject in this study also gave 60 genuine signatures. 10 genuine signatures each. So we got each subject to simulate each model 15 times, which gave us 2,700 simulations. They were collected dynamically and in hard copy form with the tablet and the software. This is what it looks like. This is one of the model signatures that was used, that I was forged, Theresa Johnson. This is a genuine signature. And below, on the slide below, shows the Movilizer image. Each red circle is a point of minimum velocity, or a turning point. So each stroke is measured within those red circles. If you look here at, on the, I guess your left is the genuine Theresa Johnson signature. On the right is pen pressure versus time. You can see here pretty high up. On the signature below, on the bottom left, is a forgery of the signature of Theresa Johnson. And to the right of that, is the pressure versus time. One interesting aspect here is that the pressure in the forgery was less than the pressure of the genuine signatures. in the question document books, you'll see that pressure in the forgeries tends to be heavier or stronger. So that was an interesting finding. This is a mixed signature. This person's name is Leah Hogue. And her movements were very, very complex. And it was fun watching people trying to forge his signature and seeing what they were trying to follow. Again, this is her pressure versus time for a genuine signature. This is a forgery of Leah's signature by the same forger from before. Again, pressure versus time, slightly higher. And this is a stylized signature. This guy's name is Nick Berman. You never know that from looking at that. Again, you can see, look also at the time. This guy takes less than 1.6 seconds to complete his signature. The forger was almost 5.5 seconds duration. So, but we've lost that in the static trace. I did a survey of all the forgers, all 60 forgers, and asked them which signature style they found most difficult to forge. And surprisingly, for me, they said the stylized. Because you look at that, there's a few squiggly lines there. They could not get the pattern. Whereas with this Theresa Johnson, it was handwriting. They could read it. They wrote it out. With the stylized signature, you're looking at a graphic pattern. Unless you have that graphic ability, you can't get it. The people who did the best, I asked them whether they had any graphic arts training, and they all did. So they all had this innate artistic ability to look at the pattern and copy it. But this signature, that really caught me by surprise, that the stylized signature people found was the most difficult to forge. You're kidding. Okay, so we get two databases. We have these again with static and dynamic signatures. What can we do with this data now, or even future databases? We can go back and look at what's been written in QD and see, is this true? Is what the examiner's saying that they see from a static signature, is that reflected in the dynamic information? And we can confirm or refute that. We can look at stroke speed, stroke size, tremor, blunt stops and starts, upstrokes and downstrokes. We can also look at impaired strokes. People with neurodegenerative diseases, dementia, Alzheimer's, Parkinson's, things like that. People using illicit drugs, medication, alcohol, and aging. We're an aging population. People in private practice come across these types of cases quite often on wills and trusts and so on, where you have people whose handwriting isn't the best because they're ill. And they're very, very difficult cases. And further study using the dynamics of what's occurring in these signatures can give us some improvement. This is an example. I stole one of Mike's slides from a presentation he gave back in February. Cannabis. It's someone writing, "Today is a nice day," on the top left, normal handwriting. This is the velocity versus time, I think. And then on the right is the person under the influence. And you can see a bit of a difference there. Look at the end there. So if you look at these two static signatures as a document examiner, you want to see that there's something different there, something happening. But what is it? Was the guy writing on a shaky table? Which I've actually heard a defense lawyer use that argument. It was a shaky table. Whenever you hear that, yeah. Okay, so proposals for future study. Research into dynamic movements, different handwriting behaviors, genuine, forged, disguised, impairment, things like that. generate dynamic bases, compare with static traces, and then impart the information to document examiners in form of workshops and training, and test them to see whether the training improves accuracy. Can we train an examiner to better estimate speed of a stroke, size? And, of course, in order to know if this is working or not, you've got to test the examiner. Okay, and that's it.
A couple of questions. Linton, can the lighter pressure in the forgery be a function of the pad or stylus?
I don't think so, because it was consistent over a number of subjects. So I don't think it was the stylus, or the pen, or the pad.
When you show the red circles marking zero velocity on the graphs, those are not the same turning points that would be counted in the complexity model, or are they?
No, they are not. That's a very, very, very good question. They are not. I mean, you look at some of these turning points and you say, they're not really a turning point. But that's where the machine is recording a turning point.
Thank you. Got one. Linton, did you find that as a percentage, that the non-text-based signatures were more successful as simulations than the more complex or text-based ones? And would you consider the non-text-based ones to be less complex signatures than the text-based?
I would have considered the text-based to be more complex than the stylized, which is why I was surprised that the subjects found the stylized more difficult to forge. But the forgeries of the text-based signatures were way better than the mixed and the stylized. I think that they would give examiners some difficulty, some of them.
The forgeries of the text-based were better
Yes.
than the stylized.
Yeah, overall.
But that sort of is counterintuitive in
Yeah.
a way. Yeah.
Yeah.
Linton, or possibly Mike on this one, following on that, with the perception of the simulator was that the stylized signatures are more difficult to do.
Yeah.
Do you think that might be because there's no inherent motor pattern that they can draw on and then adapt and change, where they might be doing that when they can read the name and, if you will, either subconsciously or even consciously invoke a motor pattern that exists?
Yeah, that's for Mike. Yeah.
I would say that's exactly well, it may not be truth, but it's the most likely answer. Yeah.
That's Emily and then Peter.
Okay, regarding those graphic signatures, my thought was that none of the complexity models seem to do anything about fluency. And it's the fluency where people really goof up, I think, on those graphic signatures.
Right. Yeah, that's a good point. I mean, complexity is just giving you one aspect of your signature. Examiners look at much more features than that. Fluency being probably one of the primary indicators of authenticity or none. Peter?
To pick up on Brent's point, could we analogize to the chess master and the chessboard layout, that if it's a nonsense chessboard layout that has nothing to do with a game that's been played ever in history, they can't remember it. But in a fraction of a second, if you show them a chessboard that is a real game, that things have happened, they'll remember it, they'll be able to follow it forever. So, because it does not compute, does not make sense. So. You're nodding. That's good.
Just one further comment about the stylized signature. One of my subjects was a retired Navy helicopter pilot who I just thinking would be good at seeing stuff. And he's trying to do the simulation. He's saying, I can see the angles, but I can't get it. So they could see that, but they just could not get those angles.
A lot of the work presented in this talk and the previous talk was based on a lot of observable variables. Is there intuition about Latin variables that are unobservable but part of the overall process, and especially intuition that is scientifically grounded about these unobservable variables that are part of the natural process of handwriting.
I can answer that. That's a good question, and I think you have to, at this stage, extrapolate to those non-observable. However, it's nearly impossible to do empirical research with them. That's the problem. Prospective empirical studies are very, very difficult to get at those dynamic features and temporal features from static traces.
Okay. Thank you.
Thank you.